My name is Esko Kokkonen and I'm a beamline scientist at the species beamline. I will give a brief update on the current status of the beamline and its end stations. Species is a soft X-ray beamline delivering photons in the range from 30 to 1500 EVs. We offer resolution up to 10,000 in resolving power at certain energies, as well as giving photon flux in the range of 10 to the 13 photons per second at the maximum. The beamline has two branches, one for ambient pressure XPS and another one for Resonant Inelastic X-ray Scattering experiments. Both branches are currently receiving general users and will be part of upcoming proposal calls. The beamline received first light in April 2019. Since then, we have been commissioning the beamline, and all the flux curves, resolutions, and beam profiles align very well with theoretical predictions. Incremental upgrades in the beamline are underway, for example, oxygen cleaning of the optics, which is expected to improve the flux at the carbon dip and above. Also, additional polarization modes are upcoming. The APXPS end station is a general-purpose UHV end station for photoelectron spectroscopy. It is equipped with all typical sample preparation tools. The ambient pressure XPS in this end station is realized through this cell-in-cell solution, where the ambient pressure cell is placed inside the UHV environment of the analysis chamber. We currently have two ambient pressure cells available for users. We have the standard cell, which is intended for catalysis research and/or reduction or oxidation studies. We also have an ALD cell, which is intended for atomic layer deposition research. The ALD cell has been specifically designed to imitate ALD reactors in the gas flow dynamics. Both cells share similar parameters in the sample environment. The maximum pressure is all the way up to 20 millibars, and the minimum pressure is, of course, the UHV environment that we provide. The samples can be heated up to 600 degrees in the standard cell and a little bit less in the ALD cell. The standard cell also provides some cooling for the sample surface if that is required. The RIXS end station is also accepting users at the moment with the so-called RIXS spectrometer. There are incremental upgrades underway in this end station. So, for instance, time gating is currently being installed to improve signal-to-noise ratio in the RIXS spectra. The end station sees both horizontal and vertical polarizations at the moment from the beamline. Sample handling system in the RIXS end station is the same as for the Veritas beamline. Therefore, there is a full interchangeability in the samples between Veritas and species RIXS. The RIXS end station will see another spectrometer being installed this winter, and once finished, this end station or the spectrometer will be able to provide high-resolution VUV RIXS in the photon energy range from 30 to 150 eV, which complements the high-resolution RIXS currently available at the Veritas beamline. I would then like to give you a few research examples that have been recently carried out at the ambient pressure XPS end station. First, I would like to show how we have recently commissioned the ALD cell, and in this example we grew platinum thin films on iridium oxide. In this case, we used the platinum-containing precursor and oxygen to grow these platinum films. In this experiment, we were dosing these precursors and measuring various core levels on the substrate during the deposition, and thereby we were able to record signal from the surface as the layers were being grown, and we were therefore able to resolve specific changes on the chemical states on the surface. Another example is the restructuring of these kind of bimetallic alloys upon exposure to different gaseous environments. In this research example, we attempted to obtain quantitative data on the kinetics of near-surface platinum tin restructuring, and as it's being exposed to different reducing and oxidizing environments. In this case, we recorded time-resolved core-level X-ray photo emission data during the repeated exposures to oxygen and hydrogen. After these modulation experiments, we saw pronounced differences in the chemical states of these specific core levels, indicating that this surface restructuring has occurred. Further information and details of the species beamline can be found on the MAX4 website, and also the contact details of the beamline staff. Thank you, and I hope to see you at Species.